Welcome back, everyone, on our theater stage here at the Festival of the Future. Our next keynote speaker doesn't need much of an introduction because you probably already know him. Dr. Herbert Diess, he's the chairman of the supervisory board at Infineon Technology. Before that, he was the CEO at Volkswagen after a very successful career already at BMW Group. And as you will discover, Herbert Diess is on a mission to make a green energy future a reality. His keynote is called From Semiconductors to Solar Power, Combating Climate Change with the Help of Technology. And after the keynotes, you will all get the chance to ask him some questions. Give it up for Herbert Diess.
Yeah, good afternoon, everybody. Thank you for having me. I'm very proud to be here. I'm a Munich-born child. I went to university here, and I'm very honored to be here invited at this venue. So, until I would say a year ago, I would have said I'm going to touch the most important thing mankind is dealing with, climate change. Now I would state it's probably the third most important thing. Most important thing is probably keeping peace, avoiding a bipolar world which would look much different to the world we have been living in. And the second most important thing, meanwhile, is AI. How to harness, how to make AI a tool which improves our life on this planet. But still, I would say the third most important question is, can we stop climate change? Hope that's working. Do I have to point somewhere?
Just a second.
Yeah. So can we still stop climate change? Can we bring it to a halt? Huh? This was probably my intervention because I wanted an additional slide. Yeah. So can we stop climate change? Can we bring it to a halt to 2 or 1.5 degrees even so? I think yes, we can. I think the possibility is there, and I'm convinced that we're going to stop climate change. Also, I had the opportunity this morning to listen to a few speakers which also brought forward some very interesting ideas involving space activities. But I think even on a conventional path forward, we can stop climate change. So why? Transportation, I've been dealing with my whole life, and I'm sure that we can reduce CO2 emissions by half. So that should be relatively easy with driving electric, transportation becomes electric, and then other means. So halving this is absolutely possible in the next 15 or 20 years or so. Others include farming. I would also say fertilizers are really an issue. Now, it's not easy. They become more expensive. But all in all, I always also would give it a 50% reduction chance in the next 2 decades. Industry is a mixed picture, so there's a big variety. We will need a lot of green hydrogen in many processes. Green steel, for instance, would make steel about 15% more expensive, but it's absolutely possible. It's being tested already now. So also I would give it a 50% chance. Building. Heating, for sure, heating we can entirely change into electric, which means would be CO2 free. Concrete is a problem. Concrete is a real issue. It's a huge, it produces huge emissions. So also buildings, I would give a 50% reduction target. The primary energy, so how we produce electricity, I think we can entirely change into carbon free electricity production. Why? Because looking at all the picture, so you would end up probably at giving it a, yeah, I would say 2/3 we can reduce with the measures we have currently in our hands. Which we only have to implement. So the basic energy production, and here I would need some help from my colleagues down there. I wanted to introduce an app to you, which is called Electricity Map. And I hope that we get it on screen, where you can see that some of the nations are already there. So yes, it's working. This is real time. This is online. And if we now click into one of the countries, let's get into Germany. We are currently producing the kilowatt hour at 290 grams. And you see it's a lot of solar currently in Germany, a lot of wind, still coal, which makes it a little bit of a problem. But, and this is one of the best days I've seen for Germany recently. And this has been 2 years ago, around 500 grams on average per day. You see that many of the countries around us are even better. Austria, then France, the Nordics, they are basically already CO2 free in production. 22 grams here in Sweden, and France for sure, nuclear is free. The positive thing is this is really continuously improving. Now I have this map, app since 3 years or so I'm using it, and it can show the entire world. Probably you can zoom it a little bit up. Yeah, and you see that it's not only Europe. There are quite some countries which can produce energy CO2 neutral or CO2 free. So that leads me to the conclusion, and then let's get back to my presentation, please. Yes, getting there. Sorry for that short delay. Yeah. So primary energy, for sure, will work. I would say we can halve the rest of the footprint. So all in all, I would give it a 2/3 reduction possibility in the if we account all the sectors. An interesting picture is as well if you look at the per capita emissions of CO2 worldwide. I think it's clear that in Qatar or in Saudi Arabia we have higher footprints. Also, the United States, Germany is in the middle. But it's quite interesting to look at the comparison between Germany. And Germany has improved a lot. 2 years ago, we have been well above 10, and now we are in 8.5 per capita. So Germany is improving. Also, probably we're discussing differently, but it's improving. Most of the countries already have peaked their CO2 emissions per capita. And what's interesting now, if you look at certain countries and compare. So why, for instance, Switzerland or Sweden is half of Germany. Let's touch briefly on Sweden. The big difference between Sweden, and Sweden is now around 3.5. The big difference is primary energy. Whereas we still use some coal in our energy production, Sweden is basically CO2 free all year round. And Sweden has a €100 CO2 tax, a taxation of CO2. That makes CO2 heavy products a little bit more expensive. Sweden is an expensive country, but if you look at the quality of life, Sweden is an industrialized country. Swedes are traveling a lot. Swedes are heating. They have huge distances to overcome. And quality of living is really good. They still eat meat. They still travel a lot. And they have a living like very similar to us. But they did their homework. And the homework is basically primary energy and a relatively high taxation on CO2. So what we can derive from that is that with 3.5 tons, we can achieve in an industrialized country only doing the basic homework. So what does it mean, 3.5 tons? Anyhow, for those 1/3 which we cannot avoid currently, we need to think about carbon capturing. There are various methods, and for sure there are also some of you working in this field. I'm quite optimistic that carbon capturing can do the job between 100 and probably an optimistic scenario about €50 per ton. Let's assume 100 euros per ton, and you know those processes, it's chemistry, it's also, you can do it with farming, you can do it process-oriented, and there are many startups now worldwide dedicating resources there. So it can be, for sure, it can be done for 100 euros, means, so 3.5 tons would cost 350 euros per capita. That's €1 per day in Germany, which is something we for sure can afford. It would be more for you probably because you're traveling more, you're flying, but it would be much less for the, let's say, less privileged part of society. So this is something we for sure can afford, and it anyhow it also will be a social, let's say, taxation, because rich people consume or emit much more CO2 than poorer people. So this makes me optimistic that we can, with a reasonable effort, to really get to a CO2-free environment. Another very positive development over the past years is that now any other nation wants to become a champion in climate technologies. There's a huge amount of investments going into these technologies. The last one, the Inflation Reduction Act, 1 trillion, half of it basically going into renewable programs, so a huge amount of money. In China, it's basically happening the same. In the EU, we're spending, I think, roughly 300 billion over the next years. There's a fund in Japan, there is Korea, and you could go on. There are so many programs worldwide. I don't think that those nations want to save the world. I think the rationale behind is to develop technologies, scale up technologies, and then sell it to the others. That's for sure a rationale. Will it work? I'm not too sure. On the left-hand side, you see that China just started much earlier with this development. China is clearly leading in batteries. Batteries play a major role in this transition. Also very strong in wind. On the lower end of this list, you see solar technology, modules, cells, wafers. China is really dominant. China is basically supplying the entire world, and you could add to this list the first wind turbines, offshore wind turbines, floating offshore wind turbines are from China. The highest voltage DC currency transmission is in China, so China just started very early and is in the lead when it comes to the industrialization of these technologies. I think that also is a great achievement. Touching on this example of solar, and you know, solar was once very strong here in Germany, but the watt peak, this is how it's going, how it's being measured, in 2010 costed about €2, and solar was just not competitive with other sources of energy. Now the watt peak costs about 20 cents. So a reduction of 90%. And in between those, between 2010 and 2020, there was this point where solar energy outcompeted basically the rest of energy production and makes solar really, got solar into this exponential development which we are currently in. 20 cents, this was right before the solar fair, which probably some of you joined here in Munich. Now it's around 17 cents per watt peak, and it continues to go down. So every doubling of the cumulative volume would mean another reduction of 25% in cost, which is going to happen quite a few times still in the next years. And that has changed this world of energy investments. So half of the worldwide investment in energy is now going into solar worldwide, from Africa, Latin America, United States, Asia. A huge part in wind, but you see solar development is really now exponential. It's basically doubling every 3 years. And whereas the fossil fuels are really now phased out. And that, once again, leads to projections for the future, which give solar really a chance to become the dominant technology for energy production worldwide. Currently, we are producing about 1 terawatt in the world. 40% of that is installed in China. And if we follow that curve, that would lead us to about 70 to 80 terawatts to really make solar the most important, most relevant, and by far the cheapest source of energy for the world. This is a prediction from Shell. You see there, Shell is not a solar company, so I give it some credibility. I would say on biomass and waste, for instance, or biofuels, they're still probably a bit over-optimistic. But solar, I'm also convinced that it's going to happen like this, because it's become so competitive, and it's just not worth anymore to dig for coal or to drill for oil. So this makes me optimistic. Solar has a disadvantage that it's it depends on the sun, and that has led already to a situation that solar energy becomes very cheap through the main hours of the day. It gets down basically to zero. We already have negative prices for solar energy in some days. Though that means we can do a little bit with the orientation. No? So instead of south, we're going east and west. It will help a little bit, but at the end, solar will need storage. Solar will need storage to make use of it. And also positive news also from China that the storage cost is really coming down. It's now flattened out because of the prices of lithium, which are stagnating, but still lithium is traded at 3 times the cost. So this will come down later. And the cost advantages I've seen now in China for the next generation gives me certainty that until the end of this decade, to store 1 kilowatt hour and to unstore would cost only a few cents anymore. So production will become very cheap. 1, 2, 3, 4 cents, and storage will become very cheap. Much cheaper than nuclear and much, much cheaper than all fossil fuels. So what does it mean for Infineon? Infineon is a semiconductor company, power semiconductors, and they play a major role in producing the green energy. So every solar farm or every solar panel on your roof needs an inverter. Every wind turbine needs a generator. Then we have to electrify everything, transport, where all motors, they need drivers, electric drivers, and then we have to transport this energy, switch from DC to AC, back to DC, and to the different currencies. This is a huge task for Infineon to supply and to promote this change. Everything basically what's possible is becoming electric. There's still a little bit of discussion now about cars, mostly here in Germany, but you see that the big advantage of using electricity is just you can use this energy very efficient. One windmill can drive or propulse 1,600 cars. If you go to hydrogen, it's 1/3. And e-fuels 1/6. So this is why electricity, not only in cars but also in heating, it's just much more efficient. We still think we have been grown up thinking molecules, all the way, but we have to think electrons. Now, wherever we can think electrons, it's just much more efficient. Then there's this argument, yes, we will need a lot more energy. Yes, we will. Now, this is a large scale until 2060, but looking at 2035, 2040, if we assume that 2035 electric or ICE cars are going to be phased out, we will need about 6% more electric energy for the mobility sector. Now, it's not doubling or some other figures you might hear. The biggest chunk in the additional electricity we need is for electrolyzers, for producing green hydrogen, which we will need in many of the industrial processes. I wanted to mention that this study or these predictions are from Aurora Energy Research. It's an Oxford team, and I highly recommend those because they have very detailed study about all countries, what are the measures in place, and I think they do very good predictions. There's another positive thing, which is, I think, very motivating, that most of the less developed countries, the south of the planet, they will skip the fossil age. They go directly into electric. This is a picture from Nigeria. Nigeria is an oil-producing country. It's a few hundred buses. Nigeria ordered 16,000 electric buses in China. They will be fed with solar panels and to be propelled. And this is not to save the planet, it's just because it's much cheaper. It's much cheaper to run those buses, even in a country which has full access to fossil fuels. And another prediction from Aurora, because there's this perception that as the other part of the world still has to go fossil and grow, that's also not true. Most of the growth and growth protections, meanwhile, are fully decoupled from CO2. So if you just pick one example there, this is China, no, the dark bubble. China still will, in this period of time, multiply the GDP or add 150%, so grow a lot, but will reduce CO2 emissions by minus 60%, basically. And Europe, even steeper, the reduction, USA as well, and there are only very few countries where we will still see an increase in carbon emissions. India, for instance, where it will grow 400% and will grow carbon emissions by 24. But also those predictions are really changing fast, and I would say next year already we will see different pictures for India. That means the world becomes electric wherever it's possible. That means we have to really prepare the gears for high voltage DC lines. Everything has to be connected. We have to see everything as an electric ecosystem. And this is the, I would call it, playing field of Infineon, where we can contribute a lot. Most of these power semiconductors today are built on silicon. We have a huge experience, we are quite efficient, but now silicon carbide and gallium nitride, the wide bandgap semiconductors, give us an additional chance for efficiency. We can switch faster, we can switch higher frequencies, and that makes switching more efficient. It allows us to make cars, give better range to cars, and also silicon carbide is used a lot in solar fields because it improves the efficiency from 98 to 99% in the inverters. Gallium nitride for this for the lower power range, also very important. This is where most of our current R&D investment currently goes in. The car becomes part of an ecosystem. The car is used as a storage device. It's charged with solar. And if you would own a house here in Bavaria, you would produce your own solar energy for about 5 cents per kilowatt hour. And with 5 cents per kilowatt hour, you already drive incredibly cheap your car. A car consumes about 20 kilowatt hours per 100 kilometers, which means 100 kilometers for €1. 1 kilometer, a cent. This is 10 times cheaper than a current ICE engine, and everybody who can do that, I think it's highly recommendable, because anyhow you need a storage device at home, and if you can charge your car when the sun is shining, and now let's assume that solar will become even cheaper, now below 5 cents, and once you have written off your installation on the rooftop, in about 10 years your electric energy is for free. So you drive for free. If you want every day 300, 400 kilometers, which makes the private car really competitive. So it will be very tough with public transport also to compete with that kind of price level, and also this kind of CO2 level. But what's important here is to see that we have to think the car as part of an ecosystem. It has to be able to charge and uncharge. It has to bring energy probably home, or it has to probably deliver energy somewhere else. It's connected. And what's interesting is the new car companies, now leading currently is Tesla. Second most important from the new age car companies is BYD. Both are producing as well storage and solar collectors, because they consider the car as part of an ecosystem. Third most important company in this new world, by the way, is Volkswagen, following close after BYD. Hopefully, they will still climb up the ladder a little bit more. We have been talking here in Germany a lot about hydrogen pipelines. It's all nice, but the real thing to do is high voltage DC lines, because they are hugely efficient. So you can transport energy over 1,000 kilometers with only 3.5% loss in high voltage DC. Here a line with 4.5 kilovolts. In China, there are already lines with running over 1 million volt, 1.1 million volt, over huge distances of 3,000, 4,000 kilometers. Now, this is the best way to transport energy. And please don't think about using the gas network we have here in Germany. It's just so inefficient. Only transforming CNG from into LNG, you lose 25–30% of the energy. The efficiency is really what I think we should really don't think anymore about modules, think about electrons. There's one concern, so many optimistic developments. One concern, which also is very important in this conference, AI. AI will consume a lot of energy because the training models are highly energy intensive. And currently the consumption of all our data centers worldwide is about 1% of the CO2 footprint, or 1% of primary energy consumption. And the predictions, if you ask now companies like NVIDIA, this can go up to 10% of our energy consumption. So really significant, really more than transportation. So we have to really think about how can we reduce it. There's also ways with wide bandgap semiconductors to reduce 25%, roughly 15 to 25%. We are working on that from Infineon, but also we have to work on the algorithm side, on the also computer side, to really drive down consumption, because if not, we would consume 10 or 20% of the entire energy of the world in our brain. This is the same like people are using probably not 20% of our energy goes into our brains, but I think we shouldn't spend as much in the new artificial intelligence compute units. So I will skip a few of those that we have enough time for questions. You can imagine that wide bandgaps plays a huge role to make cars more efficient. Silicon carbide becomes a standard in cars. Meanwhile, also for the charger, silicon carbide is a must. Gallium nitride as well. The architectures change in the car, which also makes it more efficient. We're going to 48 volts in very short time. We're going to reduce compute architectures in the car, where Infineon also contributes to make the car much more efficient. So this is why we also putting a lot of investments. Our biggest investment we've ever made. It's an amplification of our plant in Dresden, where we invested 5 billion, or we are investing 5 billion, more than we ever invested before, because we think there will be huge demand for that kind of product, and we want to produce part of it here in Germany. So all in all, I think very positive trends. So the technology is there. The question is still, can we make it? This is the best prediction I can bring currently. And this shows that currently we would end up between 2.3 and 2.5 degrees, which is far too high. We are reducing, okay, that's nice. But we have a huge implementation gap. And I think, you know, the discussion in Germany is really eye-opening currently, and we have still an ambition gap. So we need more commitments from companies and for the government. But what's positive on this slide, only last year this prediction improved by 3 percentage points. So it's coming down, and I'm sure that's going to accelerate furthermore as we have more innovations, more startups coming online, and we have better rollouts. So all in all, I'm convinced that we can make it. Yeah, we will make it, most likely. My biggest concerns are the geopolitics currently. If we really have a decoupling between China and the United States, that's going to slow down a lot. If we really have a decoupling, then we will have inflation, continued inflation, which makes the financing of startups really difficult. And if we have continued inflation, also the investment, which is huge. Many of the new applications becoming cheaper. So driving becomes cheaper, heating becomes cheaper, transport in general. So many things are becoming cheaper, but they require huge investment upfront. And if we have high interest rates, then it becomes probably very difficult to do this investment. So those two things, or this thing is probably currently my biggest concern, but technically I think we can make it, and we should ask our politicians, so please avoid to get into a bipolar, separated world, keep the world open, and then I'm sure that we can make it with all of your help as well. Thank you.
Thank you very much, Dr. Herbert Diess, for this great keynote. Well, maybe the first question from my side, I'm glad that you're so optimistic. But given that we lost our solar industry and China is now dominating the market, and also in other fields, like most semiconductors come from Asia, we have no raw materials here. So what makes you optimistic that we can grow an own solar industry again, that we can thrive in EVs, that we can thrive in semiconductors?
I think we don't have to do everything here in Europe. No, there are, and we also we're not producing oil. No, we don't have raw materials today. If we want to produce an ICE car, we need platinum. We need very rare materials which we don't have in Germany. No, as long as the world remains open, that's not a problem. And I think what's the problem if you buy solar panels incredibly cheap and make the best application here? Even I would say now this is 17 cents now the watt peak, the price. The Inflation Reduction Act now gives an 7-cent incentive per watt peak. No? So the American taxpayer is adding 7 cents as an incentive to produce that. So why don't buy it from America with American taxpayers' money? This is one solution. If you really want, and this is why I'm working on this still, if we want to be independent and free in our decision making, then we should consider have something here as an industry. And also, you have seen this huge growth of solar. So solar between 2030 and 2035 becomes bigger than automotive worldwide. So it's really one of the fastest and biggest industries. And I think Europe should participate. Now, and there will be chances in further developing solar. This is why I'm still fighting to bring solar, but it's really difficult because the Americans made when still WTO was in place and we would have called it dumping. This is a clear dumping case, but now it's probably cheaper to bring it from America.
So you can still build the solar Volkswagen of Europe. Questions from the audience, please. Raise your hand. Well, I'm starting in the front row, and then I'll work my way up there. And please shortly introduce yourself and then ask a question. Thanks.
Hi, I am Ish. I am a co-founder of a quantum computing startup. But thanks for the data. Thanks for the optimism. I wanted to ask about fusion. Where do you see fusion coming up in this picture?
Yeah, it was not on the picture. The nuclear is not competitive against solar, but fusion, I would say, is a different thing. No, I would encourage you not to stop work on fusion. It will definitely not be competitive with solar in the first years, because it requires a lot of investment. The plants will be small, but if we really want to go space, and I've learned that this morning there's so many projects really to go to Moon again and to Mars. Then we need, then solar would not be enough. With solar, if we cover about 2% of the world's surface, I think we can be self-sufficient. We can run the planet. But if we want to leave the planet, we definitely need fusion. So I think it's worthwhile working on it.
Thanks for that. And just a promotion, the very first keynote tomorrow on the stage will be on fusion. Here was another question.
And there are quite interesting startups here in Munich for fusion.
Hi, my name is Jakob Scheitzer. I'm a storytelling coach and engineer. And as an engineer...
This is a storytelling coach and engineer.
Storytelling coach and engineer, yeah. You heard it right. Wild mixture. And from an engineer perspective, I love the idea of beating the climate crisis just by technology. So if I listen to your talk, I really get optimistic and be like, yeah, we can do it. Here comes the but. I think we need behavioral change. So if you look at your optimistic scenario of the 1.5 degrees, how much behavioral change do you think do we have to include?
Actually, I don't think a lot. I don't think a lot if you once again make up the numbers. Now in Sweden, there's very little behavioral change. They travel a lot. They eat meat. They heat their homes, and they are in 3.5 tons. And in the developing country, we are talking not 3.5 tons, we are talking 300 kilos or so, or 30 kilos, no? Which will not increase too much because they will go into renewables right from here. So we basically we have to deal with 3.5 tons. And what I say is that carbon capturing, and I don't know whether there are startups here in the room, but the figures I have in mind is really between 50 and 100 euros per ton. Yeah? And at the end, we have to. One other, and we could do it today, because if for 100 euro today, it's already possible. 150, I would say 200 euro is possible. Let's assume it would be possible for 100 euro. You have Saudi Aramco, the most valuable company of the world. What are they doing? They're producing CO2, basically. Yeah, so basically they're producing CO2. And in a very nice business model. No, they are so expensive because they dig it out or they get it out of the ground for about $8 to $9 the barrel. And they sell it for, today, I don't know, 70, 75 the barrel. That makes decent margin, yeah, which makes a very valuable company. If you would apply those 100 euros to get and one barrel is 159 liters or so, is about 400 kilograms of CO2 on average. No, it depends on the process, 400 kilos. So if you would add those 40 euros or $40 to the price, they still would make a huge profit. Yeah, they still would have a 40% margin or so. Yeah? So even they could, and they are kind of privileged because in many parts of the world it's more expensive to get the oil out of the soil. But even they could keep basically free if they would reduce their margins substantially, no? Because $40 or 40 euros is important. But I think it can be done. It's technically feasible, and we've studied so many different ways to carbon capturing. And I think also in Germany they are very promising. Chemistry, also in mechanical carbon capturing, filtering will end up below 100 euros per ton. And this is why I'm also a bit skeptical about the very expensive technologies. Now, molecules, if you think hydrogen, we have to get it out of solar. Hydrogen, lose 50%. You have to compress it. Hydrogen is 14 times lighter than air now, so you have to compress it a lot, 800 bars. You lose another 15%. So it becomes hugely expensive. And in some of those expensive technologies, I just see it will be cheaper to just get the and it's probably something in Germany we don't like to think about, no, because sequestration, carbon capturing, we're not allowed to talk about this, but this is different in the rest of the world. Yeah.
But we do like hydrogen here a lot.
We love hydrogen, and I'm not saying hydrogen is hydrogen will play if we think industrial processes. Hydrogen is a must. Now, and we will need the 10 years capacity of hydrogen, and also the cheap solar energy will help a lot to produce hydrogen efficiently. No? So we will need a lot of hydrogen. I'm not saying that. I'm not sure whether we need a hydrogen pipeline or something like that, or transport hydrogen from one continent to the other, because it's not going to work. Yeah.
Well, we have another question. I misread the signs the person over there gave me. So he wants to yell. So please try.
Loud.
You wanted to, yeah, it's your question, your chance.
Einfach laut sprechen.
Yeah. What do you think about the renaissance of the desert tech area?
Yeah, absolutely. Absolutely. Yeah. Yeah. Absolutely.
Just
absolutely. Yeah. 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 Yeah, absolutely.
Just,
and there's some positive
repeat,
news.
Just repeat the question for those who didn't hear it. What about a revival of the plans for Desert Tech?
Desert Tech. Yeah, Desert Tech. Desert Tech is absolutely the right approach because you use high voltage DC, which is 1,000 kilometers is 3.5% loss, and it comes direct. And northern part of Africa is fine. And the good news is that other nations are really considering. There's a big startup, and they are well financed for the first phase to basically put solar and wind in huge quantities into Morocco and draw a line around Europe to the UK. And they are already in the, let's say, base studies, shipbuilding, which would cost about 25 billion. Yeah, between solar and wind park, and it's a huge line to get around Europe. It's if you look at the figures, it's feasible. It's a profitable project because with those 25 billion investment, they can produce energy for about 2 billion in half a year, so 4 billion a year. So it's a decent business case, long-term business case. No, and then I'm also sad that it didn't work out. So for Germany, going to Africa, it would be much cheaper. Yeah? Or for Italy, think about Italy, it's a few hundred kilometers. Yeah, and it's much better than thinking about producing somewhere hydrogen and ship it. Yeah.
Yeah, but we do have those LNG.
Yeah, and I think there's still a revival considered for Desert Tech. What I've heard, which would make a lot of sense.
Great. We got another question down here. Still, yeah. I'll hand it over to you.
Hey, I'm Martin. First of all, thank you for the contribution to the change happening in the German automotive industry. I have the feeling this is sometimes overlooked if you read just the headlines from the press. So I think that was very important.
I'm happy with my performance of that.
Rightfully so. So thanks for the positive note. I think you're spot on with many of the long-term developments. So cheap energy production and also storage. Also, I think the climate change is the third most important topic. Like AI is, I think, more important, and also like keeping the peace and always looking for peace is like more fundamental as well. So my question is, I have the feeling in Germany the discussion is always about policy making and also like personal sacrifices, whereas my picture is more we need to change the economy and incentivize entrepreneurs because every change on such a large scale must be produced through the economic machine. So what needs to change, like in incentives for entrepreneurs, for capital, for entrepreneurship in Germany?
I fully share your view that we are over-regulating. No? Let's say a law which is discussed half a year for heating systems in houses, no? And another law for traffic, and another law for... And that's not the way to do it, because you don't make use of the market, and the market would work. And Sweden shows it. No? What we really have to make sure that CO2 gets a price tag. That CO2 is available. And then the industry makes a job. And the industry switches from concrete into wood where it's possible. And the industry makes the efficiency calculation. Much better than if you sector by sector try to regulate. And on the other hand, also you get so much opposition. No? Because every time you make a new law, you will hurt somebody and put somebody in disadvantage. But we had the discussion for me. Because actually it was a mistake to start with cars. Because the car is relatively expensive. Now, to avoid a ton CO2 emissions in cars is more than 100 euros. It's probably 200 or so, at least at the beginning. No? But nobody wanted to keep the market to the job. Everybody was scared about the CO2 tax of more than 20 euros, which is nothing, no? Because 20 euros you don't see in any of your bills. So 100 euros is I would say the minimum. And then it's so complicated because we are so overregulated. We still have 4 billion incentives every year going into diesel engines. Yeah, we can't take it away because our politicians are fearful. Yeah, and we can't. Yeah, and we still have subsidies in coal. Yeah, which is it's very difficult. And with this impetus here in Germany to regulate everything, we make it worse. And I'm really sad about this discussion we have in Germany now because the climate change is for entrepreneurs is an opportunity. Yeah? And we rarely had more opportunities in the world for new enterprises, for new business models. Yeah? It's for people who want, and it's also attractive because you know what's going to happen. Yeah? The world is heating up. CO2 is getting more expensive. We will become more electric. So you can do a 5 or 10 years plan. You might be wrong in 1 year or in 2 years, but it's for entrepreneurs, it's an ideal world. What the problem here is that we are over-regulating. How to change that? I don't know. I don't know.
Well,
we love it. Yeah? We love it. We had today this discussion about AI, no? And Europe is first in regulating AI. Yeah? We don't have any. Yeah. Sorry, I didn't want to.
So you met so many politicians, and you still think that there's no mind
they also
change here?
They are also in there now. They have their constituencies and their lobbying groups, and they can't. And there are very few politicians which really look forward and say, "I do what's right," and many are focused to get over their next elections. No, and many are focused about the yellow vests in France or the right-wing parties here in Germany now, which are still telling us that there is no climate change. So the politicians, it's not easy. It would need a little bit more forward. And I think we have to give it a positive momentum. That's what I'm trying to do here. Yeah? The new world is much better than the old world. Yeah.
Great. Yeah.
Okay. Thank you.
Here's another question. Oh, okay.
No.
The question was already answered. Then
okay.
You can maybe yell and then I'll repeat.
Yeah.
Hi, I'm Greta. Just a very short question. Does Infineon actually invest in carbon removal companies? Or
no. So I'm speaking here not as many of the slides. They have been Infineon slides because it's kind of it fits well together, Infineon and what I think is right. But the let's say the aspects about how we seeing the world with which technologies is not Infineon. Infineon is really focused on semiconductors. We are investing in startups, but not in carbon. We would if there is some switchgear needed for we would, yeah.
Great. Here's another question over there.
Hello, I'm Julia, and thank you so much for your talk. I think it was really inspiring, forward-looking, and giving good ideas. I've recently attended an event around capital markets, and as a CEO, you were probably also exposed to the discussions around the capital markets. And on that event, they were saying they are wondering if we as Europe, or especially also Germany, have the right capital market to finance startups, to finance this climate change. Yeah. What is your view on that?
Oh, you're absolutely right. We don't have. And this is kind of, it has different aspects. We just discussed it before. The Anglo-Saxon world has these huge pension funds which are allowed to invest in venture capital, which we don't have in our system. Basically, not even the big insurance companies like Allianz, they can't invest, they're not allowed. And that makes a big difference. This difference means that in America, for instance, America spends 0.08 percentage points of their gross national product in venture capital. In Germany, this is less than a tenth. And then scaling this down, this is basically nothing. So I'm very happy that we have some American capital coming here and feeding this huge talent which we have here, because at least the ideas grow and it's at the end, I think it doesn't matter so much whether it's German capital or any other Western capital. And then we have, for sure, we have a mindset thing, which I don't feel, I'm very happy to come back here to Munich after 7 years and to see what happened here in 7 years. No, this TU Munich is now probably the biggest venture capital university in Europe, ahead of Berlin. There's a lot of happening. This venue shows. So I'm very happy that we have a lot of talent and it's growing, but financing is a problem. Also, a mental. A problem of mentality. we are more risk adverse here in Europe. Now we call it Risikokapital. No, in America it's called venture capital, no? Wagniskapital. It already sounds a little bit different. And then we have, I would say, a company like Tesla. No, 15 years losses, 15 to 20 billion burnt. They would not in Europe would not have the patience to do that. No, I think it's impossible. You need very, I would say, strategic, long-term investors, funds. So America is just a better place. Also, another figure which might be interesting for you, from the, I think, top richest, the 10 richest people in America, 9 are founders currently. Yeah, 9 are founders. In Germany, from the top richest 10, 8 are heirs. So it's not only the pension funds, and I think we should just open up and work with the American capital if it's coming. It's nice, it's democratic, and we can make good use of it. Okay, bit lengthy,
but very interesting. What car are you driving right now?
I'm driving a Golf. I ordered an ID.3 because I couldn't get an electric car because they were sold out. But it seems that they're getting back now to.
Great. One last question. Thank you so much for this great Q&A session. On one of the last charts you were showing, there was this lack of ambition gap.
Yeah.
How to overcome this?
Yeah, I think I hope that. Over time, we get a positive momentum into this. No, that people will see that electric cars are not as bad as people tell, and that a heat pump is actually cheaper than, and that solar it comes really for very little money. So I think we have to get into this positive momentum. And also, what would help Germany is that we are very much focused on inside, no, and there's so much happening outside. No, for instance, in India, which is a big polluter. I don't know whether you've seen it on the slide. They have a lot of coal-fired power plants still, but they're not investing anymore in coal because solar has become so cheap. Yeah? And electrification starts there. And you look at Africa. Africa, meanwhile, is a big installer in solar. So this is open up a little bit. I would also hope that in the next year you should be probably a bit more international, invite people from the rest of the world, because
you can help us with your network.
We Germans tend to then see everything. Oh, it's so difficult, and it's yeah.
And he's still smiling, saying that when he has been CEO of Volkswagen for quite a while. Yeah. Thank you so much, Herbert Diess, for joining us and giving this great keynote. Thank you so much.